Formal charge. The formal charge of an atom in a polyatomic molecule or ion may be defined as the difference between the number of valence electrons of that atom in an isolated state and the number of electrons assigned to that atom in the Lewis structure. The formula we can use is formal charge is equals to total number of valence electrons in the free atom minus total number of non-bonding electrons minus half the total number of bonding electrons. Of course, we can use this formula to calculate the formal charge, but I have an easier way with the help of which you can calculate the formal charge easily. So I have made this table for the purpose where you can see I have made 3 columns, out of which the first column shows where the formal charge is -1, and as you can see the covalency of these atoms is less than expected, whereas in the second column the covalency is as expected and the formal charge is 0, and in the third column where fluorine and carbon are present as their cationic species, nitrogen and oxygen are having more than expected covalency. So you can correlate covalency with the formal charge. So I have given the examples further. You can check on the examples. As you can see, ozone, where the central oxygen is showing more than expected covalency, so it has a positive charge, whereas the one with the negative charge is showing less than expected covalency. So here you can use that. It's not some standard formula or standard derivation something. It is just for the convenience of calculation, and you can always cross check with the help of formal charge formula. So this PF5 where the formal charge on each of the atom is 0, H2SO4 where again the formal charge on each of the atom is 0, and there we have NO2. Here it is a little bit different because nitrogen, it is an odd electron species. Nitrogen is showing expected covalency, but still it has a positive charge, which you can understand with the help of oxygen. Here you can see that oxygen is showing less than expected covalency, which means oxygen must be bearing negative charge, and since the molecule is neutral, you will have to check on the electronic configuration very carefully, and then you will know that nitrogen has donated 1 electron to oxygen. That is why nitrogen will bear a positive charge and oxygen will bear a negative charge.